welcome to this evening's live. I've just been having a little 5-minute chat with people on TikTok because that's been ready for 5 minutes, but everyone else I know is only just visible to you. And in fact, I think Instagram, you've literally only just gone live because I forgot to press the go live button, whereas YouTube, you've probably been live for a little bit of time already. And I'm just trying to find where the stream is just so I can check how it is looking on those two channels, just to make sure it's all lined up nicely. Yeah, so YouTube's looking good. Instagram's probably going to be 5 minutes. Oh no, cool. I can see everything and it's looking good. So we are going through immunity today. We did do immunity on Halloween the 31st, so a month ago, but we're focusing more this time on, well, I can show you. We've got a question here that we're going to do linked to phagocytes. We've got a question. Oh, where's the rest then? Huh, that wasn't what I was expecting to see. Oh, it's these ones then. So describe how vaccine leads to a production of antibodies. We've got one here about vaccines. We've got passive and active immunity. I've got a few questions here from my active recall workbook just to lead into it, and phagocytosis. So let's actually start then with this here from the active recall workbook, which, as I was just saying to TikTok, that is within the bundle, which my Black Friday deal is now live. If you click the link in my bio, if you're on my email list, you'll get sent it straight away. But if you're not, if you click the link in my bio on Instagram, I've got the link to my Black Friday deal. It's 40% off my Big 3 bundle, which is bundled together my active recall workbook, which is this, as well as my notes and also my flashcards. So that's what you get on the Black Friday deal. It's only live until Saturday, so you've got about 45 minutes. Right, let's get into this one here then. So we have used the graph to describe and explain the primary and the secondary immune response. So that's what we've got on this question. So for this one, what we can see is our primary immune response. That's the first time you are exposed to a particular pathogen. We have a lower concentration of antibodies because the peak is lower. And also the gradient of this line isn't as steep as the gradient of that line. And that tells us that it's a slower production and you have fewer antibodies being made. So that's one thing that I'm going to say. So primary, I'm just going to do shorthand as that, just so I can fit it all in. So primary response equals fewer antibodies and slower production. But we also have to explain why. So the reason that it's going to take longer is it takes time for the cell-mediated and humoral response. Basically, that clonal selection, which is when the correct shaped B cell collides with the pathogen, that's going to take time because that B cell is going to be floating around in your blood. It has to collide with that correct, the correct shaped receptor on the B cells to collide with that antigen on this new pathogen. So clonal selection. So all of that takes time. Whereas the secondary response, we have faster production of antibodies and higher concentration. And that's because there are memory B cells, which when exposed to the same antigen, they differentiate rapidly into plasma cells. And those are the cells which create the antibodies. So that's that first bit. Then we've got here that we need to contrast passive and active immunity, which that was one of the questions that is coming up in the exam questions. So contrast passive and active immunity. I'm going to see if we've got any ideas coming in the comments. Right, first of all, just answering some questions. This is A level, it's AQA, but it will be relevant for all exam boards because this is parts of immunity which are relevant for all of them. So even if you're OCR, yes, this will be good. Right, let's just see if there were any other questions or answers coming in. Okay, right, let's jump into this then. So we've got to compare and contrast our active, in fact, no, it's not. Yeah, it's just contrast. So not compare, we're not looking for similarities. We're just finding differences. Contrast, passive and active immunity. So I'm going to say passive is when antibodies are introduced. Into body, whereas active is when exposed to antigen, so make own antibodies. Squeeze it all in. Next then, passive doesn't provide long-term immunity. Because I'm short of space, I'm just going to say isn't long-term. Active is. And then the third one, I've actually kind of linked up here, but the next one is active. You have plasma cells. And actually before that, I'm going to say memory B cells. That, if you can read that, that says memory. Oh, that's so bad. I'm going to have to rewrite it. Memory B cells. Oh, and it's moaning about that one as well. So let's try that again. Plasma cells and also memory B cells are created for active, but they're not for passive. So let's then go back to the exam question. So this was 5 marks, this exam question. Immunity can be active or passive. Describe the difference between these two types of immunity. So we are describing, describe the difference between these two. So we don't want any similarities. We're just focusing on differences. So some of them then we've written down on that active recall page already, but I'm now going to add in some here. So one of the ones I'm going to go for is active involves memory cells, and you always have to have the contrasting statement, so passive doesn't. Then leading on from that one, I'm going to say active involves production of antibodies. And passive doesn't. Then one of the points we had was that passive immunity involves the introduction of an antibody, whereas active is the introduction of either a weakened pathogen or an antigen. So passive involves introduction of an antibody. Active is introduction, which could be by an injection or it could be a nasal spray. Vaccine doesn't actually mean injection, it just means the introduction of either a weakened pathogen or an antigen. There's different ways to get that into the body, like toddlers often have nasal spray, particularly if it's the winter flu vaccine. Right, we've got 1, 2, 3, we need some more. We said passive is short term. whereas active is long-term. One, two, three, four. It's 5 marks. We still need some more. Describe the differences between them. Oh, another one linking to this graph would be, it would take a longer time for you to actually have any antibodies if it's active, because it takes time to produce those antibodies, whereas passive, you're injecting it in immediately. So let's have that as our last one. Active can take time for antibody production. Passive is fast acting. And there we have it. That is 5 marks linked to passive and active immunity. Let's see what this question was. Describe how a vaccine leads to the production of antibodies against a pathogen. So vaccine leading to the production of antibodies against a pathogen. There's some similar concepts here to what we were just looking at in that graph. We could, I don't think I actually printed off, or not printed, but copied over the page. Oh no, here it is. Let's do this as our little stepping stone before doing the question, because that's what I like about the Active Recall workbook. It's guiding you into that particular point. So we've got this fill in the gaps activity. This is a great one for the chat box for you to be able to take part, because it's nice and quick. So small amounts of something or dead pathogens or something are introduced orally or by injection. So it could be a liquid drop. It could actually be a nasal spray as well. So for this one, small amounts of something. I reckon TikTok will have answers in already. Okay, I can see some answers coming in on TikTok. Excellent. They're saying weakened. So I need to zoom in so I can actually write this neatly. So we have a weakened. So small amounts of weakened or dead pathogens. Or what else could it be? Yeah, antigens. Excellent. Are introduced orally or by injection. Exposure to the antigens activates the something to go through something expansion and differentiation. The clonal selection bit in brackets here, that's actually when the correct shaped, or the B cell with the correct shape receptor on the outside is selected for to divide by mitosis and then differentiate. So that's what we've got here. The exposure of the antigen activates the B cells to go through clonal expansion and differentiation. B cells undergo something to make large numbers of cells which differentiate into something cells or something cells. So they undergo mitosis. So it's mitosis cell division to make lots of copies, identical copies, which differentiate into either plasma cells or, I'm going to zoom in to do memory B cells. Plasma cells make antibodies. B memory cells divide rapidly into plasma cells when reinfected with the same pathogen to make large numbers of something rapidly. So that would be antibodies. So there's just a little recap before we then have a look at that long answer question. So let's go back to the exam question that activity led to. Describe how a vaccine leads to the production of antibodies against a pathogen. So first thing that I'm going to say is what the vaccine contains. So vaccine contains the antigen for the pathogen. then, oh, I forgot to turn my phone off, vibrate, probably just heard it vibrating there. So the next thing we could have is T cells with complementary receptors or receptor proteins bind to antigen. Those T cells will then activate the B cells. So I'm going to say stimulate / activate the B cells. And it's going to be activating the B cells, which also have the complementary receptors on their surface, because that's how the T cells will activate the B cells. The receptor on the T cell binds to the receptor on the B cell that has the correct complementary shape, and that is your idea of clonal selection, selecting the correct one. There we go, complementary. So that's the one it would select. Then I'm going to say B cell differentiates into plasma cell and memory B cells. And plasma cells make antibodies. So large amounts of antibody. How have we got? This was a 5 marker. 1, 2, 3, 4, 5, 6. There we go. I reckon that would cover it. Right, so we've done that question. We've done this one. We've covered that bit of the book. I'm going to go to this final question then to finish. So we have phagocytes. Let's highlight. Phagocytes are types of white blood cell. We have to describe how phagocytes destroy a pathogen for 4 marks. So the first thing that I'm going to say is that the phagocytes are attracted to the pathogen due to the chemicals it releases. So attracted to the pathogen due to chemicals it releases. Next, it engulfs the pathogen. Pathogen is then encased in a vacuole. Which I'm going to put in brackets as the phagosome. Then a lysosome fuses with the phagosome. And that releases lysozyme into the vacuole. And I'm going to say lysozyme enzyme digests, and you could say digest or hydrolyzes the pathogen. Right, 1, 2, 3, 4, 5 marks for that 4-mark question. That would definitely cover all of those points. And that is it today. I'm just doing a quick 20-minute one today, but we've gone through 3 exam questions, some of the activities within my active recall workbook, which if you weren't here at the start, I was saying my Black Friday deal is now live. Just click the link in my bio to access it. It's 40% off my big 3 bundle, which means you get 40% off buying collectively this active recall workbook my notes and my flashcards, and all three of those cover the entire theory for AQA A-level biology. And between those three resources, that should pretty much be you set for your A-levels, apart from free exam questions that you can also access. But those three resources are my best sellers. That's why I bundle them together, and that's why I'm giving 40% off them to give you that little bump boost before your mocks for your A-level biology. But that is it for today, everyone. Hopefully you found it helpful, and I will see you next Thursday.